Okay, I've had a request to work a few problems from the summary post-test, and I've just pulled out a few of the fraction problems. Your numbers are probably different from mine, but you should be able to follow along with these examples and work your own. First problem is 1/3 times 3/8. There are two ways to work a multiplication problem. The first method is you multiply straight across, 1 times 3 over 3 times 8, which will give you 3 over 24. And then you should recognize that you can reduce those, divide both by 3, and you end up with 1/8. The alternate way of working it is you can reduce on the diagonals before you multiply. Now this only works for multiplication. You can reduce up and down in multiplication. You can reduce on diagonals. You just cannot reduce straight across. But if I divide this by a 3, I get a 1. Divide this by a 3, I get a 1. And now if you multiply straight across, you have 1 times 1 is 1, and 1 times 8 is 8. You get the same answer. You tend to deal with bigger numbers this way, but it's easier to understand. You do have to reduce at the end. This is really nice when you see it. You can also use a combination of things. Maybe you start canceling things out on the diagonal, but you miss some things that you could cancel out, and you still end up with something you need to reduce. Okay? Let's look at 1/9 divided by 7 over 6. The rule for division is you keep the first one, change it to multiplication, and flip the second one. Okay? Now we have a multiplication problem that's going to work the same way this one did. We can reduce on the diagonal here. Of course, the 1 and the 7, that does nothing. But 6 and 9, those are both divisible by 3. If I divide the 6 by a 3, I get a 2. Divide the 9 by a 3, and I get a 3. Now let's multiply straight across. 1 times 2 is 2. 3 times 7 is 21. That does not reduce any further. That should be your answer. Okay, so now let's add fractions. What I'm about to do here works for subtracting fractions as well. With addition and subtraction, you must have a common denominator. So I need to figure out what to turn these denominators into so that I can rewrite my fractions so I can add them. Okay? We talk about finding the least common denominator, and what we're looking for is the smallest number that both of these numbers divide into evenly. One way of doing that is to take your larger denominator, which is 5. Ask yourself, does 3 go into 5? No. Take this number and double it. Does 3 go into 10? No. Take this number and multiply it by 3 to get 15. Does 3 divide into 15? Yes. Does 5 divide into 15? Yes. So 15 is your least common denominator. This will work if you start with a smaller number too. You're just going to have more steps. So generally speaking, it's better to start with your larger one. One backup plan, and this is not like highly recommended, but you can always find a common denominator by multiplying the denominators together. It may not be, it often will not be, the smallest option. You'll be dealing with all big numbers, you'll have a lot to reduce at the end, but it will always work. One more thing, if you are multiplying or dividing, we do not need a common denominator. However, if you find a common denominator before you multiply or divide, you can still get the correct answer. So what I'm saying is adding and subtracting, you need a common denominator. Multiplication and division, you don't. But if you get confused about when you are supposed to have a common denominator and when you don't, default to go ahead and finding a common denominator. It won't work here. It won't hurt here. But if you don't do it, you're going to get every addition and subtraction wrong. Okay, so we decided our least common denominator was 15. So I'm going to rewrite this problem with 15s in the denominator. What we need to do is to ask ourselves, 5 times what gives me 15? 5 times 3 gives me 15. If I multiply the bottom by something, I need to multiply the top by something. So 1 over 5 is the same thing as 3 over 15. Okay, now I'm going to do the same thing here. 3 times what gives me 15? 3 times 5 gives me 15. So I need to multiply the top by 5 as well. So that gives me 5 over 15. Now the rule for addition and subtraction is once you have a common denominator, you get to add or subtract across the top, and the denominator stays the same. So this is 8 over 15. And I looked to see if this reduces at all, but there's nothing other than 1 that divides evenly into both 8 and 15. So 8 over 15 is your answer. Okay, so let's look at these mixed number problems. The first thing we're asked to do is to estimate. And estimating with decimals, most people find pretty easy, because like if I gave you 7.932, if I were rounding to this spot, I'd look at the 2. 2 is not bigger than 5, so the 3 would stay the same. However, if I were multiplying to this part, the 9 is bigger than 5, so this would jump up to an 8. The problem is that this is not written in decimal form. There are 2 ways you can do this. 5/7 is the same thing as 5 divided by 7. So if I were to write this as a decimal, I would have 0.71428, so on. The 7 tells me the 5 would jump up to a 6. So my estimate is going to be 6 divided by 7, which is 6/7. Okay, that's one way of doing it. Use your calculator to find the decimal part to figure out how to round. The other way of doing it usually doesn't require a calculator, and it's just a little trick, okay? If I want to know if 5/7 is bigger than or smaller than 0.5, I can multiply the top by a 2 to get 10/7. Since 10 is larger than 7, I'm going to round up, okay? Now imagine for a second I had 3/7 instead. If I multiply that by a 2, I have a 6 over 7. 6 is not bigger than 7, so this would stay the same. And if I did the division, 3 divided by 7, you'll see that the 4 would not make this jump up, okay? So my estimate is 6 over 7. Now I'll do the exact one. That's written poorly. That's a 7 right there. We need to change this to an improper fraction, and we do that by 5 times 7 is 35. 35 plus 5 is 40. So I have 40 over 7 divided by 7. I'm going to write it over 1. Keep it, change it, flip it. 40 over 7 times 1 over 7. Nothing reduces, so multiply straight across. 40 over 7 times 7 is 49. This does not reduce, so this would be my answer. Let's see how close these two things are. I'm going to do 6 divided by 7. This is just sort of a way to check myself. 0.85714. And let's do 40 divided by 49. And I get 0.8. I'm having trouble here, 16. These are reasonably close for division. Your estimates for division and multiplication are going to be further off than a division for addition and subtraction. Okay, I hope that helps.